So guys, here we are going to look at a filter method. It's one of those important in the streams chain or pipeline that you can use. So for instance, let's say we want to filter out numbers here. Maybe we can just say odd numbers, for instance, in a stream. So what we could do, we could say stream dot filter. So this filter, remember filter is a predicate, and a predicate has a method called test that takes one parameter and returns a boolean. So if we were to describe this lambda, we would say x is that parameter, then the type, because it's a stream of integers, inferred. So we can then say x modulus 2 equals, since we say we are filtering out odd numbers, equals to 0. We are only going to get even numbers, and the odd numbers would be filtered out. So this is how normally this would go about. I'm just gonna remove this and I'm gonna do this. So I'm gonna do this, and then now what I can do here is I can collect this and make it a list, another list, integer, we can say even, let's just say even. Then if we print out even, it should only give us all even numbers, and all odd numbers must have been filtered out. So let's run this code. As you can see, it's giving us all even numbers. So you see that when you have a functionality that has multiple lines of code, you can now take this out, because normally with lambdas, a lambda is not really supposed to be a long code. 2 lines might be too many. But if your lambda just requires you to have 1 line, it's fine. The minute it has 2 to 3 lines, the recommendation is to take out that code and put it in a separate function. So we can do something like this. We say boolean, okay, public static boolean even. Then what we do, we say int x, then we say return. So what are we returning? We are just returning x. So the advantage of taking out the functionality outside is so that you can unit test it separately and just plug it into the lambda, into the code as a lambda or a method reference. So at the moment we can say even, and we can pass x. As you can see, the functionality now that is embodied in the lambda here is not defined in the lambda itself. It's defined somewhere else. We just plugged it in. And now there's a better way of actually doing it. We can actually use the class name and do it as a method reference. We can do like this, and then we can remove this one. Then our code will work fine. Then we are doing the filtering. So filtering will always work the same. for streams that are not primitive streams, in a sense that well, they will always work the same. So let me explain what I want to say here. So assuming you had let's say you had a primitive stream. Now we had int stream dot of I want you to observe that the filter method of a normal stream, which is not specialized, takes a predicate, and this predicate is Boolean test t. So now we are going to compare it with the filter method of a primitive string. So what we will do here, we're gonna say in stream.filter. So you see that this one takes int predicate. So let's see this int predicate. It's just a functional interface. It takes an int as a value and returns a boolean, which is almost similar here. It's just that this one it's generic, but this one it's not generic. So that is the difference that you will see with filter methods between the normal streams and the primitive type streams, the specializations of the stream. Otherwise, everything should remain the same. So if we were to implement this, we would say, and obviously we are taking one parameter x, then we can say x modulus 2 equals 2. Okay, sorry, equals to 0. Yeah, so we can do something like this. So this x, you can put it in a bracket, but since it's 1, you don't really need to put it in a bracket. You can also specify that it's of type int. So you have a lot. So I think we did cover those things when we were doing lambda expressions. So you can have this, or you can still plug the same method reference here. Why? Because this even here, it's similar to the definition is similar to this definition. It takes an int value, returns a boolean, and this one even takes an int value and returns a boolean, hence it's able to work fine. So if I execute this code, I say dot boxed dot collect, and then I say even 2, and then I print even 1, even 2. I should get the same result. As you can see, I get the same result. Let's say that I had another method here called ought. So all I need to do here is to say 1, and then let's say here we just want to take the odd numbers. As you can see, the output below.